Hello everyone, myself Vinay Kumar. I'm actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. In my previous videos, I was actually discussing the third chapter of 9th standard science subject, that is atoms and molecules. So in this particular video also, we will see the further concepts which is there in this particular chapter. So in previous videos, I was actually discussing about atoms and also I discussed about Dalton's atomic theory and also about atomic mass. So in this particular video, we will understand what are all molecules are. So molecules are the particles which are actually formed due to the arrangement of certain number of atoms. So this particular atoms, they combine with each other with a particular attractive force. Because of this particular attractive force, when atoms are attracted to each other, they form a certain molecule. And that particular molecule can be a compound or can be a simple element as well. For example, if I take oxygen as an example, oxygen cannot exist as just O or just as a single atom in nature. So oxygen will always bond with another oxygen atom. So two oxygen atoms will be bonded together to form one oxygen molecule. Similarly, if I consider hydrogen, even hydrogen cannot exist as a single atom. That particular hydrogen will also combine with another hydrogen atom to form H2, that is a hydrogen molecule. Like this, every atoms will combine together to form a particular molecule, or atoms of different elements can also combine together to form one particular molecule. So if you consider a compound, the smallest simple particle of that particular compound can be known as molecule. For example, if you take water in a particular container, so this particular container contains indefinite number of H2O molecules in it. So one single H2O can act as a molecule. So here two hydrogen atoms are combining with one oxygen atom to form this particular H2O molecule. So this actually shows that atoms of different elements or atoms of same element can combine together to form one particular compound or one particular simple element. So this actually forms a particular molecule. So and one particular molecule can exhibit the properties of that particular substance. For example, if you are considering water, then this particular single H2O molecule can alone exhibit all the properties of water. That is, if you consider water as a bulk, then a single H2O molecule in that particular water or every single H2O molecule in that particular water can exhibit the chemical nature of that entire substance. So every H2O molecule will exhibit whatever chemical nature or whatever chemical properties that particular water is having. So that particular chemical properties every single H2O molecule can exhibit. So a molecule can also exist as a single simple particle which can actually have same chemical properties of that when it was there in a bulk. So this can also be considered as a property of a particular molecule. So there are some noble elements also in the periodic table like argon, helium. So such kind of elements can exist as a monoatomic element, and even helium can exist as a monoatomic element. But oxygen is not a monoatomic element, because oxygen, single oxygen atom cannot exist because it is very unstable. So that's why always two oxygen atoms will be combined together to form oxygen molecule. Hence, oxygen element is known as a diatomic molecule. But argon and helium can exist as a monoatomic molecules. Similarly, if you consider nitrogen, nitrogen also is very unstable as a single atom. So that's why one nitrogen atom will be combining with other nitrogen atom to form nitrogen diatomic molecule. So this particular nitrogen exists in the gaseous phase. So this particular nitrogen will always have two nitrogen atoms as its composition. So two nitrogen atoms combine together to form nitrogen. So nitrogen is also a diatomic molecule. Even if you consider hydrogen as an example, hydrogen also cannot exist as a monoatomic molecule. So hydrogen will also exist as a diatomic molecule. So if you consider phosphorus as an example, phosphorus also cannot exist as a monoatomic. Phosphorus exists as a tetraatomic molecule. So what do you mean by tetraatomic? 4 atoms will be combining together. So 4 phosphorus atom will be combining together to form this particular phosphorus. So if you consider sulfur as an example, sulfur exists as S6 or S8 in nature. So here 6 sulfur atoms or 8 sulfur atoms will be bonded covalently together. So that's why sulfur is an example for polyatomic molecule. Polyatomic molecule means a molecule which contains 3 or more atoms bonded together to form a particular molecule. So that kind of molecules are known as polyatomic molecules. So here sulfur exists as S6 or S8. So that's why sulfur is an example for polyatomic molecule. So when atoms of different elements or same elements combine in a definite proportion, then they actually form compound. So atoms of same element or different element, they combine in a definite proportion. So when atoms of same element or different element combine in a definite proportion, then they actually form a particular compound. So what do you mean by definite proportion? Definite proportion means same amount of mass ratio of that particular atoms should be maintained throughout that particular compound, and also same ratio should be maintained, and also the number of atoms combining together should also be fixed throughout that particular compound. So for example, if we are considering water as an example, so in water we have H2O as its chemical composition. So here always 2 hydrogen atoms will be combining with 1 oxygen atom. So this particular combination of atoms should be there throughout that particular water, and the ratio, the mass ratio of hydrogen and oxygen should be 1:8 only. So here if you consider 2 hydrogen atom, that is actually 1 AU plus 1 U, that is 1 AMU plus 1 U is the atomic mass of hydrogen. So when I consider 2 hydrogen atoms, then it will be 2 AMU, and the mass of oxygen will be 16 AMU. So 2 AMU is the total mass of 2 hydrogen atoms, and 16 AMU is the mass of one particular oxygen. So now if you take ratio of these two, then 2:16 will be 1:8. So 1:8 is the mass ratio. So hydrogen is to oxygen mass ratio should be 1:8 throughout that particular water, and 2 hydrogen atoms should only combine with 1 oxygen atom, and this particular molecule formation should be there throughout that particular water. Then only this can be known as a compound. So this particular one particle of water, that is H2O, can be known as one molecule of water. So this is actually molecule of a compound. So what do you mean by molecule of an element? A simple element which exists in the nature can be known as molecule of one particular element. Here we are forming a molecule of different elements as well. So this can be known as molecule of compound. So here H2O is one particular molecule of water. That is, water is a compound. So one molecule of compound is H2O. So the next concept which is there in this particular chapter is ions. So what do you mean by ions? So ions are basically charged species. So if you are considering a molecule or a compound, in that particular compound, part of it will be positively charged and part of it will be negatively charged if you are actually splitting that particular molecule. So for example, if you are considering NaCl as an example, here sodium atom will be positively charged, Na plus, and this particular chlorine atoms will be negatively charged, that is Cl minus. For example, if you just consider Na plus, then Na plus can be known as an ion. If you just consider Cl minus, then Cl minus can be known as an ion. But when you togetherly consider NaCl, then this particular NaCl is not considered as an ion, because here positive charge of sodium is balanced by the negative charge of chlorine. So here NaCl is not an ion. NaCl will be a compound or this particular NaCl can be known as a molecule. But when you split this particular NaCl in a particular chemical system, at that particular time you will get positive charge on Na and negative charge on Cl. So that at that particular time Na plus can be known as positive ion and Cl minus can be known as negative ion. So the total charge of NaCl is 0. But if you consider individual charge of sodium, then it is positively charged ion. If you consider independently the chlorine ion, then chlorine ion is negatively charged. Basically, ions are charged species, charged chemical species which are positively or negatively charged. So if you want to understand how this positive or negative charge is there on this particular elements, then we have to understand what is there inside an atom. So what and all things are there inside an atom, like electrons, protons, neutrons, all these things you should learn, and then you will understand how a particular atom will get positive charge or negative charge. So all these things you will be learning in 4th chapter. So in 4th chapter you will be learning structure of atom. So in that particular structure of atom you will get more details on this particular ions, and also you will get more details about what is there inside an atom. So as of now in this particular 3rd chapter, ions are basically charged chemical species which might be positively or negatively charged depending upon the atoms or elements which you are actually considering. Now coming to the next concept in this particular chapter, how a particular compound is formed or how to write a particular chemical formula. For example, if I consider water as an example, then I will write the chemical formula of water as H2O. How to write this particular chemical formula? So now there is a concept known as valency. So again about valency you will be learning in your next chapters. So as of now you can understand valency as the arms of a particular element. So for example, if you consider human being, a human being will be having 2 arms. So here the capacity of this particular human being is 2. That means he can catch 2 hands at a time. Now, if you consider octopus as an other example, an octopus will be having 8 arms. So here, octopus can catch hold 8 arms of different human beings. So now, how many human beings is required to satisfy all the arms of this particular octopus? And also, how many human beings are required in such a way that all human beings' hands should be satisfied and also all hands of octopus should be satisfied. Now, each human being will be having 2 arms and one particular octopus will be having 8 arms. So, now 8:2 ratio is there. So, if you take 4 human beings, then 4 into 2 will be 8. That means, if you consider 4 human beings, then 4 human beings altogether will have 8 arms, and all those 8 arms of 4 human beings can catch hold the 8 arms of octopus. So now you can see all the hands of octopus is occupied and also all the hands of all 4 human beings is occupied. Now this will be a stable molecule or a stable compound. For example, if I consider H2O as example, here to form a stable H2O molecule, the valency of hydrogen and oxygen should be considered. Only when the valency of these 2 elements are considered, it should be satisfied in such a way that valency of both the elements are satisfied. That means, if I take an example of octopus and human beings, 4 human beings are required to catch hold all 8 arms of octopus, and also each human being will have 2 hands, and when they catch 2 arms of octopus, then 4 people are required to catch hold of all 8 arms which are present with octopus. So this is how elements with different valency in periodic table will form bonding with different other elements in the same periodic table to form a stable compound or to form a stable molecule. You can consider H2O as an example. You can consider methane, that is CH4, as an example. You can consider nitrogen as an example. You can consider carbon dioxide as an example. You can consider carbon monoxide as an example. So all you should remember is that what is the valency of that particular element, and with which element that particular valency can be satisfied, and also the valency of other elements should also be satisfied, so that that particular compound can be stable in nature. So you can also understand this in terms of charge. So the net charge in a particular compound should be balanced out so that all positive charges cancels out negative charges. For example, if I take NaCl as a compound, here sodium has one particular valency where it can form Na plus ion, and chlorine will form Cl minus ion. Here the positive charge of sodium is cancelling out the negative charge of chlorine, and is at this particular time there can be a stable bond formation between sodium and chlorine. So how this is possible? For this to understand, you should have an idea about how many electrons are there in chlorine and how many electrons are there in sodium, and you should also understand how the valence shells in a particular atoms are there. To understand all these concepts, you should refer next chapters. So I'll be explaining next chapters as well, so you can refer those videos also. So as of now, in this particular chapter, to understand how a particular compound or how a particular molecule is stable in this particular nature, to understand that, you can consider the charge on individual element or individual atom present in a particular compound, or you can consider the valency of that particular individual atom or element which is present in that particular compound. Now I will just give examples of some atoms which has different charges on it. So based on that, we can actually see how bond formation between those atoms can be made. So now hydrogen has H plus, that is one positive charge is there on hydrogen atom. Now if you consider potassium, potassium also have one positive charge. If you consider silver, Ag is the symbol for silver, that also has one positive charge on it. If you consider copper, copper also have one positive charge on it. Now if I consider magnesium, magnesium has two positive charge on it, so Mg2 plus. And if you consider calcium, calcium has 2 plus. And also if you consider aluminium, aluminium has 3 plus. So here 3 positive charge are there on this particular aluminium atom. So now let us take examples of atoms which have negative charges on it. So if you consider chlorine, chlorine has Cl minus. If you consider bromine, then bromine has minus, 1 minus. And if you consider iodine, then iodine has one negative charge on it. Now if you consider oxygen, then oxygen has two negative charges on it. If you consider sulfur, then sulfur has two negative charge on it. Now if you consider nitrite, then nitrite has 3 negative charge on that particular nitrogen atom. Now based on this particular data, you can see what elements can bond with what elements. Now if I consider hydrogen and chlorine, hydrogen and chlorine can form bond with each other, because H plus and Cl minus, if they combine together, then one positive charge and one negative charge of Cl and hydrogen will get cancelled with each other, and there will be HCl molecule formation. Now if I consider hydrogen and bromine can also form a bond as HBr. Now if I consider hydrogen and iodine, then Hi can be the compound. Now if I consider hydrogen and oxygen, at this particular time, one H plus cannot satisfy two negative charges of oxygen. Here hydrogen has one positive charge, oxygen has two negative charge on it. So to balance out this particular two negative charges of oxygen, you can consider two hydrogen atoms, because one hydrogen atom will have one positive charge and other hydrogen atom will be having one positive charge, and this particular oxygen atom will be having two negative charges. So one positive charge of one hydrogen and one negative charge of oxygen, and one positive charge of another hydrogen and one negative charge of oxygen will get cancelled out each other, and two hydrogen atoms can form bond with one particular oxygen atom to form H2O as a molecule. This is how you should actually write a particular chemical formula of a compound. Now if I consider aluminium and if I consider oxygen, the charge of aluminium is 3 plus and charge of oxygen is 2 minus. Now how to balance 3 plus charge with 2 minus charge? So now To balance out this particular charge, you can multiply 3 plus with 2. So when you multiply 3 plus with 2, you will get 6 plus. And if you multiply 3 with this particular 2 minus, then you will actually get 6 minus. So now you can easily cancel out this particular 6 plus and 6 minus charge. So that means here 2 atoms of aluminium will be combining with 3 atoms of oxygen. So how it will be combining? Al2O3 will be the combination. So here when you take Al2O3, at that particular time you are considering 2 aluminum atoms. So one aluminum atom will be having 3 plus charge. So when you consider 2 aluminum atoms, it will be 6 plus charge, and one oxygen atom will be having 2 minus charge. So when you are considering 3 oxygen atoms, 3 oxygen atom total, it will give you 6 minus charge. So 6 plus charge and 6 minus charge will get cancelled each other, so that there will be a stable compound formation, that is Al2O3. So this is how you should actually write a particular chemical formula. So now if I consider magnesium as one particular element, and if I consider chlorine as another element, and if I want to form a stable compound between magnesium and chlorine, then here charge of magnesium is 2 plus and charge of chlorine is 1 minus. So here 2 plus should cancel 1 minus, which is not possible. So now I'll multiply this particular 1 minus with 2. So it will give me 2 minus. So that is 2 plus charge will cancel out 2 minus charge to give you a net neutral charged compound, that is MgCl2, because here 1 Mg atom should combine with 2 chlorine atom. So when there is 2 chlorine atom, so 2 minus charge will be there, and Mg already have 2 plus charge, so that 2 plus and 2 minus gets cancelled with each other, and there will be a stable bond formation and there will be a stable compound formation. So that is actually MgCl2. And one important rule which you should remember is that when a particular non-metal is combining with a metal, so if non-metal atom is combining with a metallic atom, then metallic atom symbol should be written first. That is, if calcium is a metal and if oxygen is a non-metal, and if calcium and oxygen are forming bond with each other, that is actually CaO. So when you write CaO, you should always write Ca first and then you should write non-metal. You cannot write this as OCa. Here non-metal should not be written first, metal should be written first instead of non-metal. So that is CaO. So this is wrong and CaO is right. So always you should write metallic atom first and then the non-metallic atom. So here calcium is a metal and oxygen is non-metal. So Ca is written first and oxygen is written second. That is CaO. This is one particular rule which you should actually remember. And coming to the next rule, here if you are considering two elements giving you the total net charge. For example, if I have a OH ion, then this particular OH ion will have negative charge on it. Why? Because here we have only one oxygen atom and one hydrogen atom. So hydrogen atom will be having plus 1 charge and oxygen atom will be having 2 minus charge. That means one particular plus charge of hydrogen will be cancelled by one negative charge of oxygen, and one more negative charge will be remaining as it is on this particular OH minus ion. This OH minus ion is not stable in nature, so this will be combined with a particular atom. So for example, if this particular OH is combining with Mg atom, so this particular Mg has 2 plus. So here you can see this particular Mg has 2 plus charge and this particular OH has 1 minus charge. That's it. So here 2 OH minus ions is required to satisfy 1 Mg 2 plus. So here Mg has 2 plus as its charge, OH minus has only 1 negative charge. So you should consider 2 OH ions, and this particular OH minus ions and this particular OH minus ion, that is 1 minus and 1 minus charge will get cancelled with this particular 2 plus charge of Mg, and there will be a stable bond formation. And always you should write, when you are taking 2 OH ions, at that particular time you should put a bracket for this particular OH and write 2 after this particular OH in the bottom part of that particular bracket. So MgOH twice should be written. So for example, if you are combining OH minus with sodium, sodium has only one positive charge. So here easily this plus and this particular minus can get cancelled with each other, because here only one plus charge is there and here also one minus charge is there. So this particular one minus and one plus can be get cancelled with each other, and there can be a stable bond formation. At that particular time, no need to write this as NaOH1. This is not required. When there is only one particular ion is there, that is OH is there, then you can straight away write this as NaOH. Now, if there are two OH ions involved in the bond formation, at that particular time you should actually put bracket like MgOH. So you should put bracket for this OH and twice. So if you are putting 2 outside this bracket, means this particular 2 belongs to this particular OH. So for both oxygen and hydrogen, this particular 2 is belonging. So for example, if I write the number behind a particular compound like this, if I take 2H2O, then this particular 2 will be applied for both hydrogen and oxygen. But this particular 2 which is there with hydrogen will be applied only for this hydrogen. So when this particular 2 is written to the left hand side, then this 2 is applied for both the elements. So if you want to understand formation of bonds in terms of valency, then if you consider hydrogen and chlorine as an example, here valency of hydrogen is 1 and valency of chlorine is 1. So this particular valency will be there for hydrogen and this particular valency will be there for chlorine. So there will be a bond formation between hydrogen and chlorine and you will get an HCl compound. Now if you consider carbon and chlorine, then carbon has 4 valency, chlorine has 1 valency. So that's why only one carbon atom is enough. But here to satisfy valency of carbon, 4 chlorine atoms should be there, because valency of carbon is 4. So that's why 4 chlorine atoms should be there to form bond with this particular carbon. But here chlorine has only 1 valency, so only one carbon atom is sufficient to satisfy all 4 chlorine atoms. So like this you can actually form bond between carbon and chlorine, because here valency of carbon is 4 and valency of chlorine is 1. So in this way also you can understand how compounds are actually formed of different atoms. So how to write a chemical formula using charge? You should be knowing what is the charge of a particular element and you should try to balance out that particular charge with another element. For example, if I am considering Mg and if I am considering chlorine, then charge of Mg is 2 plus and charge of chlorine is just 1 minus. So here 2 plus should be balanced with 2 minus. But here only 1 minus is there. So you should take 2 chlorine atoms. So at that particular time 1 minus and 1 minus will account for 2 minus. So 2 minus will cancel 2 plus and there will be a stable bond formation between Mg and 2 chlorine atoms. So at that particular time you should not write MgClCl. This is wrong. You should not write 2 times chlorine. Instead of that you can write MgCl2, because if you are writing in this particular position of a particular element, then this 2 is belong to only this particular atom. Here if you are writing 2 MgCl2, then this particular 2 is applied for Mg and chlorine as well. But here this particular 2 which is written for this particular chlorine is applicable only for this particular chlorine atom. So this 2 will be applied for both Mg and chlorine atom. Both the chlorine atom, this particular 2 will be applied. So coming to the last concept which is there in this particular chapter, that is molecular mass. So now you have understood what is atomic mass. If you have not seen the video on atomic mass which I have posted before this particular video, please refer that video and understand what is an atomic mass. So after understanding atomic mass, understanding molecular mass will be very easy. So what do you mean by molecular mass? Molecular mass is just the sum of individual atomic mass of atoms which are involved in a particular molecule. So for example, sum of individual atomic masses. So for example, if I consider water, then in this particular water molecule, you have 2 hydrogen atoms and 1 oxygen atom. So individual atomic mass of 2 hydrogen atoms and 1 oxygen atom, if you sum up them, then that will be the molecular mass of hydrogen and oxygen. So what will be the molecular mass of H2O molecule? So for H2O molecule, to calculate this, you can consider atomic mass of hydrogen. So what is atomic mass of hydrogen? That is 1 AMU or 1 U. So here two hydrogen atoms are there. So it will be 1 U plus 1 U, and one oxygen atom is there. So atomic mass of oxygen is 16. So now you can add all these three. 1 plus 1 plus 16 will give you 18. So 18 atomic mass unit is the molecular mass of this particular H2O molecule. So if you want to find molecular mass, that is the mass of a particular molecule, then you can add the individual atomic mass of that particular elements which are involved to form that particular molecule. So in this particular chapter you have example 3.1. In that first A question they have asked to calculate relative atomic mass of H2O. Here atomic mass unit will be applied for individual atom. When you consider molecular mass at that particular time, you should always use the term known as relative molecular mass. So now I have already calculated relative molecular mass of this particular hydrogen atom, that is 18U, because 1 plus 1 plus 16 is 18. Similarly, if you come to B question in this particular example 3.1, there they have given HNO3 as the molecule. So now hydrogen is one atom in this particular molecule, nitrogen is one atom in this particular molecule, and there are three oxygen atoms in this particular molecule. So what is atomic mass unit of hydrogen? 1U. What is the atomic mass unit of nitrogen? That is 14U. So for oxygen it is 16U. Here three oxygen atoms are there, so you should do 16 into 3. So 1, 14, 16 into 3 will give you 16 3s are 48. Now you can sum up all these. So 1 plus 14 is 15. So 15 plus 48 is 53, 63. So 63U. So this 63U is the relative molecular mass of HNO3. So there is one more concept which is known as formula unit mass as well. So if you are actually calculating the relative molecular mass of a definite compound, then that particular relative molecular mass is known as formula unit mass. So for example, if you are considering a definite molecule or a definite compound where ions are involved in that particular compound. For example, if I consider sodium chloride. So formula unit mass is basically applied for a compound which has ionic charge involved in that particular compound. So for example, if I consider NaCl, NaCl has charge Na plus and Cl minus. So here ions are actually involved in the bond formation of these two atoms. So in these particular cases, whatever molecular mass you will find out, that molecular mass is known as formula unit mass. Similarly, if you are considering CaCl2, here also you are considering the charge of Ca and chlorine. Here charge of Ca is 2 plus and charge of two chlorine atoms will be Cl minus and Cl minus. So here also ions are involved in formation of this particular compound. So here also if you are finding molecular mass of this CaCl2, that is actually known as formula unit mass. So what is formula unit mass of NaCl? Same way how you find out molecular mass of different compounds, for formula unit mass also you will follow the same procedure. The only difference is name will be different, that is formula unit mass will be the name. So here to calculate formula unit mass of NaCl, again you can consider the atomic mass unit of sodium and chlorine. So the atomic mass unit of sodium is 23 and there is only one sodium atom, so 23 into 1 plus one Cl atom is there, so atomic mass of this particular Cl is 35.5 into 1. So when you add this particular 23 into 1 plus 35.5 into 1, at that particular time you will get 58.5 as your answer. So this will be formula unit mass of this particular NaCl molecule. Similarly, if you look at example 3.2, in example 3.2 you should find out formula unit mass of calcium chloride. Here also you can just find out the molecular mass of this particular CaCl. So what is the atomic mass of calcium? Atomic mass of calcium is 40 and there is only one calcium atom, so 40 into 1 will be there, plus there are two chlorine atoms, so 2 into 1 chlorine atom will have mass of 35.5, so 2 into 35.5. So 40 plus 2 into 35.5 will be 71, so 40 plus 71 will be 111. U. So 111 U is the formula unit mass of this particular CaCl2. So all these concepts are there in this particular chapter. In next chapter, we will be learning about structure of atom, what is there inside atom and what happens inside atom, all these things, and also how atomic theories were developed. All these interesting concepts we will be learning in next chapter, that is chapter 4 of 9th standard science. So if you want to learn more physics, chemistry and mathematics like this starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.